Hi guys, in this video I'm going to go over the Google slide for area of a sector and length of an arc. So first we're going to cover how to find the area of a sector. So the sector is a fraction of the circle. It goes to the center, so it represents however many degrees is always out of 360 degrees. Basically we're just dividing the area of the circle by the fraction of the circle that we know we have. So the formula, this is the formula that we're using. And so n is equal to the angle. So the angle divided by 360. And then pi r squared, that's how you find the area of the entire circle. So in this example, I would be doing 60 degrees divided by 360. That's going to tell me the fraction of the circle. This is the entire area of the circle. So pi r squared. And then just plug that into the calculator and get your answer. Sometimes we do something called leaving it in terms of pi. If I wanted to leave this in terms of pi, it's not really going to work out good for this one. But that basically just means that you would figure out what 60 over 360 times 8 squared is. And that comes out to be 32 over 3. And then you just leave the pi symbol in your final answer. So this is what it looks like when you do something in terms of pi. You basically just do the math for all the other numbers. You don't plug pi into the calculator at all. You just put the pi symbol on your answer. All right, so the next slide is using that formula. So I'll do a couple of these, and then I'm going to let you do the rest of them on your own. So the first one, find the area of the circle. Not the circle. This, I'll draw these in. These are your little sectors here, just in between the two radii. All right, so this one, I'm going to look in, your answer choices are over here for how you're going to set up the equation. So it's the angle over 360 times pi r squared. The radius of my circle is 30. So if I look at my answer choices, I'm sorry, it's not going to let me click on them. You just drag the green one over to where I've written it down, and we're just going to type it in the calculator now. So 10 divided by 360 times pi times 30 squared. And I got 78.5. All right, in this case, we're finding the missing angle. So the angle gets divided by 360, multiplied times pi times the radius squared, but this time they've told me that it equals 30. So I'm going to solve this for x, or n, whatever you put there. So pi times 10 squared, I'm going to simplify that. So this is the same as n over 360 times 314 is equal to 30. So to solve this equation for n, I'm going to have to divide by 314, and I'm going to have to multiply by 360. So I got 34.4. All right, and I'll also do one where you have to find the radius. So my degree over 360 times pi r squared, and I know that the area of that sector is 30. So you can do this a bunch of different ways. I personally would just go ahead and multiply by 360. So I'm going to do that first. And then 10 pi is just a number. It's being multiplied, so I'm going to have to divide both sides by 10 pi. And then the radius is being squared. So my last step is going to be to take the square root. So I'm going to do 10,800. I'm going to divide that by, and in the calculator, I'm putting that 10 pi in parentheses when I click divide. So the calculator knows to keep the pi in the denominator. So I got like 343.77. And then the last step for this is going to have to be to take the square root because r is being squared. So my final answer for this is about 18.5. All right, so you can drag the equations that we used and you can just type in the boxes, but you can do these three on your own. So I would pause the video here and do those three. Sorry if that's making a horrible squeaking noise. All right, to find the length of an arc, we're actually going to do it two different ways. First, we're going to do it in terms of a radian. So a radian is another way that we can measure angles going around a circle. So a radian is equal to the radius of the circle. So in this picture, this red arc that you see I have drawn, that arc is the same length as a radius. And so that means this angle in here is 1 radian. This angle, Q, is equal to 1 radian. A lot of times radians are in terms of pi, but they can also be converted. That's one of the things that we're going to do is convert back and forth between degrees and radians throughout the year. So these little pieces are there for you to drag over. And I'm going to just drag mine kind of quickly. Let me see if I can get out of this. So if you drag these, it doesn't have to be perfect, but it should be close enough that you can kind of tell. Each of these is equal to the others, and they all represent a radian because the red part, that arc, is the radius of the circle. And so you should see it all kind of fits right in there. This last one should kind of fit right where that line is. So if you notice how many radians there are in this circle, this is 1, 2, 3, 4, 5, 6, and this little sliver that didn't quite make it. That little sliver is because 2 pi, 2 times pi, is like 6.28. And so that means 6 full radians plus that 0.28. That's why the circumference of a circle is the formula 2 pi r, because 2 pi is the length all the way around a circle. And so when I put all my radians together, it completes the circle and adds up to 2 pi. So a radian basically is just a better way of representing a fraction of a circle, because that's just the definition of it. So this is the formula that we're going to be using. S is just the letter that we use to represent the length of the arc, and that symbol is going to be the radian measure. R is the radius. So this is a formula. If you have a degree and you want to convert it to a radian, that's what you would do. So like if you had 60 degrees and you wanted to convert it to a radian, that would be the same as pi over 3. So 60 degrees and pi over 3 radians are the same thing. The radian formula just involves a lot less work because you literally just have to do the radian times the radius and then you're done. All right, so to fill in those blanks, a circle contains 2 pi radians, which is also 360 degrees. All right, so these is pretty straightforward. These are just those formulas. I'm trying to erase that dot. Sorry, guys. So number 1, because this is a degree, I would do 40 times pi over 180. That's going to get it into a radian. So really, the only thing you should be typing in the calculator is figuring out how to simplify 40 over 180. And that comes out to be 2 over 9. So that means it's the same as 2 pi over 9. So to find the arc length, this is the arc that we would be finding. I just have to do that radian times the radius. The radius is 8. So only the numbers should actually get typed into the calculator. Don't type pi in. I mean, you can if you want, but that's not the way I leave my answers. So I would leave this as 16 pi over 9. All right, now this one is already in radians. So again, it's just the radian times the radius. For 3 and 4, you're kind of working backwards. The arc length is 20, so that's what S stands for. Find the radian measure, so that means I don't know my radian. Given the diameter is 10, well, my formula needs the radius. So if the diameter is 10, the radius is 5. So that's just a simple equation. Just solve that equation for x, and that is your radian measure. So 4 radians, and that's it. All right, so you can try to finish this circle question down here, and you can finish number 4. All right, you should be able to do slide 5 the same way, and you don't have to worry about that. Right now we're just doing the length of the arc. And I am going to show you there is a way to do it in degrees without converting it to radians. So the degree formula, you can do the angle over 360 times 2 pi r. So similar to the area formula, we still have that degree of our angle divided by 360, but this time this stands for the circumference of the circle. So if I wanted to find the length of arc LM, if you wanted to do it in radians, you could, but you would have to convert 100 degrees to a radian first. But I can use this other formula for degrees and just do 100 over 360 times 2 pi. This time it says my radius is 5. And just plug that into the calculator. So do what you can. We'll go over this when I see you tomorrow.